So I've been talking for 3 minutes non-stop. And I've been muted the entire time. Crazy. Okay, let's start again. Okay, how to appear dumb on a Monday morning. Okay, everyone, hello. Now I'm feeling embarrassed, actually. I'm feeling incredibly embarrassed. But I think that's what streaming is about, actually. Okay, so let's start from the beginning. It happens Monday mornings, exactly, my guy, exactly. Okay, so hello everyone, my name is Dudezord. Welcome to my 5th week of streaming. It has been an incredible month of streaming so far. I streamed like the entire month of March, and today marks day 21, and I'm having a lot of fun. I've met a bunch of cool people in the platform, a bunch of new friends now follow the channel. Hello Burnseye, hello Siege Lord, some of our newer followers, and yeah, for this week I will want to try a new, not a new schedule, but a new programming schedule. So instead of doing development in the mornings and gaming in the afternoons, I'll just try to do development the entire day and see how that goes. I will still split the stream in 2 parts, so like the morning stream and then the afternoon stream, and each section will be its own project. So I'll see how that goes. I'm trying to figure out how Twitch actually works. It's very complicated, although it might not seem, but there's a ton of sliders and knobs that you can tweak to try to grow your community. So I'm just trying stuff, actually. So for this week, or for this morning, I will continue working on the Gameboy emulator, which is a project that I started because it was my first console that my grandma gifted me around 30 years ago. And I mean, it's been an amazing project to do. It's very fun. Although sometimes I might appear extremely overwhelmed on stream because it's just so much information that you need to keep track. But I mean, it works. Once you go past it, well, the chroma key is a little bit junky, like here on this corner, weirdly enough. So let me maybe bump the light here. GG, fixed. Okay. And yeah, we'll start with the Gameboy emulator on this morning. And then for the afternoon stream, we have a new secret project that we will start today. From the same owner of the Unreal RTS game, we have a new project from him that he wants us to work on. So yeah, a new project on stream that I'll be able to show you guys and work live on it. So yeah, I think we might as well get started with the Game Boy. Making sure that the scene transitions. It does, good. So this is the Game Boy. Okay, once it compiles, you have like the neat scrolling Nintendo logo, and then it tries to launch Tetris, which is currently crashing. Okay, like it's crashing because Tetris has a new set of instructions that the original boot ROM didn't have. So now we should just be trying to do that. Although I found one issue. On stuff that we worked on Friday. So on Friday, we noticed that when booting the Tetris game, it would essentially be stuck on an infinite loop. And the reason for that was because we were not tackling anything regarding interrupts. So no interrupt handling was ever happening. Which means that if the user would press a button, the game wouldn't try to intercept that command. Same thing for if you have like automatic timers, the CPU wouldn't stop and try to run that instead, and only then jump to where it was before. So that was essentially the cause for the boot loop. The issue is we try to implement that, and the way that we implemented that is we need to check if we have this flag enabled, this IME flag enabled. Maybe I can scroll up here. Yeah, we need to check if we have this IME flag enabled, and if we have an IME flag enabled and then we have like a matching interrupt enable and interrupt flag for either joypad, serial, timer, LCD or VBlank, we need to handle that interrupt immediately prior to executing that instruction. The issue is that I took a shortcut. Yep, the issue is that I took a shortcut. Because the shortcut that I took is that I'm now calling this instruction called 16, and I'm saying, okay, do this, but then, okay, call. So for example, for the VBlank interrupt, you'll see that when interrupting for VBlank, you need to jump to address OX40, which is essentially what we are doing here. But then when you return from that interrupt, you need to come back to the last instruction that you were running. And so the shortcut that I took was that I, instead of implementing the entire thing properly, I was reusing call 16 to do this. The issue with call 16 is that it doesn't push the current instruction, or it doesn't store the current program counter on the stack. Instead, by default, it is pushing program counter plus 3, because 3 is the length of call 16 when it's interpreted as a regular instruction. So what this means is that when we do this, we are essentially skipping 1 or 2 instructions that we should be running pretty much every time. Because instead of doing this call 16, we should actually just be doing whatever call is doing inside, but without the jump, without the offset of 3. So we need to do that, okay? And that's the first issue that we have. And then we have a second issue. And the second issue is that whenever we handle an interrupt, we need to clear the interrupt flag for that interrupt, which we are never doing. So this might mean that we essentially get stuck again on a boot loop trying to handle the same interrupt over and over. So we'll need to fix that as well. So we have 2 fixes to do before we start implementing stuff. And the reason why I found this is because we were essentially implementing a ton of instructions just to make sure that Tetris would boot, and I couldn't feel when it was going to end. Like, we were just doing more instructions and doing more instructions and doing more instructions and implementing opcodes that we didn't have. And I mean, it was going and going and going. And I thought, no, okay, I thought for myself that no, there must be a problem somewhere. And this is the problem. I think this is the problem. So yeah, let's get cracking on this. Sounds good? Good plan? Good plan. Okay. How do I want to do this? How do I want to do this? I would say that instead of this FN 16 like this, I might as well do something like a call helper. Yes, a call helper. where here we can put, for instance, an offset to the program counter, which for call 16 will be 3, but for interrupts will be 0. Yep, for interrupt will be 0. So I think that will be the thing that we need to do. So instead of all of this, we might as well just do a call helper where we pass 3 and value. GG. Elgardia redeemed first. Congratulations, my guy. Hell yeah. Welcome to the stream, Elgardia. And happy week. Okay, I think these should be essentially done, more or less. For this. This is the best song on the entire playlist. And instead of executing this, like a maniac, I might as well do call helper of 0. You need E1 M1 on that playlist. That doesn't go on the vibe of the playlist at all. I like fusion jazz stuff. It is light. Okay. Well, paste the URL here because the bot is already storing URLs that I can take a look at later, and then I will decide. Sounds like a plan? Okay. I think this will fix the first part. So now this will be 48. This is going to be 50. This is going to be 58. Good job. This is going to be 60. Okay. And maybe this boots now. That's like the fun part about this. Like maybe this will boot. Okay, cool. It didn't boot, but that's fine. That's fine. Okay, I'll see it later. Just to show you that I'm not lying. This saves the URLs here on my super secret channel. Yeah, because LitGeek the other day posted some link about LLMs, and then I lost the link, and then I was like, nah, I need to create something that saves these links automatically. Okay, first part is done. Hopefully. The second part now is clearing IF. The bit on IF did it. Good job, me. Good job, me. When an interrupt requests signal, changes from low to high. This is set. Double execution. Okay. The IF bit and the IME flag are reset by the CPU. Okay, so we are already resetting IME, but we'll also need to clears IF. So for instance, here we have like if register.lcd equals 1, and this is bit number 1. And we'll need to grab this value, which, I mean, this is a register, but I think I can transform it into a U8. And then I will need to do set bit on this. This is bit number 1. And I want to put a value there. Something like this. Change type of parameter binding function set bit to U8. What do you mean? Oh. I mean, this won't work, my guy. Let I value equals IE. Well, I don't need for IE. Okay, this is just dereferring it, so it turns the structure into a U8, and this will set the bit here. And then what I need to do is I need to write okay, the pointer will be a value U16, and this will be a IF address, which will be this. And then here will need to be a value U8 of if value. I think it's this. Ryzen Ryken followed you. Thank you. Thank you. Hello, good morning, Ryzen. My name is Dudezord. I've been streaming. This is my second month of streaming, or the first day of the second month of streaming. And I do game development stuff. And sometimes I play games, but mostly I do game development stuff. I've been doing game development stuff for over 5 years professionally. But now I'm between jobs, so I figured, why not try streaming? And I'm having a lot of fun doing it. So welcome to the stream. And if you have any questions, please feel free. Today I'm working on my own Gameboy emulator because it was my first console, essentially. And I've always wanted to build an emulator for myself. So what better excuse could I have, right? So that's what I'm currently doing. But yeah, welcome to the stream. This one is for you. Hooray! Okay, so this is bit 1. Hold on, let me. Okay, so v blank will be bit 0. I mean, I can already tell you I don't like this code, but it is what it is. This is going to be bit number 2. Yes, bit number 2. This is going to be bit number 3, serial. Good job. And finally, but not less important, bit number 4 for the joypad interrupt. Now, I wonder if this might be a no-op because of the PPU running, you know? Because of the PPU running. I see, I do programming too, but for finance trading. I usually open on coding lives, even if I don't understand the language. I'm looking forward to talk about programming. Yeah, then I think you found a good stream to do it. I've been working with Rust, which is the language that I'm using professionally for over 3 years. I had a pretty bad experience with it because I wasn't allowed to use like a proper IDE. We didn't use any unit tests. I didn't have a debugger. I couldn't set breakpoints, a bunch of stuff. So it was always a console log debugging experience, and I hated it. And I hated the language because of it. But now, at least we are using a proper IDE. I can use the debugger. We built some unit tests already, and I'm having a better time this time around. The reason why I chose Rust is just because it's currently the language that I still feel the most comfortable with. Using proper Rust instead of Rusty Rust, yeah. I mean, Rusty Rust is what I used prior to this. So this is rust-free Rust. Yeah, I'm afraid of this right here. I'm afraid of this right here. They don't tell me anything regarding if so to give you some context, we have the CPU running like as a separate thread, then we have the PPU, pixel processing unit, running as its own thread, and the CPU is doing their own instructions right from the RAM, the bytecode stuff, and the PPU is reading from video RAM and then pushing pixels onto the LCD. But the PPU has several modes that it can be running on, and depending on the mode that it's currently running, the CPU might have or not have access to parts of RAM. And I wonder if it lets me do this. I mean, no, this shouldn't be an issue because this if address doesn't fall inside FFOF. Sorry, this write instruction won't fall inside OAM or video RAM, right? It only fails if on this FF. Yeah, we are safe. GG, we are safe. No need to worry. Okay. So this will work. I don't like this code at all, but this will work. You should try a game jam sometime while you are between jobs. Jobs could be a lot of fun. Maybe. I would really enjoy building a Game Boy game. But that's a secret. That's a secret. The objective as well is for me to build the emulator. And once I build an emulator, I'll build a Game Boy game, and I will maybe implement multiplayer into my emulator, and then we can all play the same Game Boy game over the internet. And I already have an idea of the game I want to build. But that's all secret. That wasn't supposed to be spoiled today. So yeah, that's some secret news only for you. So don't tell anyone, please. Okay. Do we think this works? I mean, maybe. I mean, this is setting the bit properly, and then it's writing the bit to IF. So maybe this will work. I mean, let's see. Okay, cool. It still crashes on the same instruction that it was crashing before. I still have one thing to fix here, by the way. which is regarding this EI instruction, which, if memory serves me correct, we need to do it multiplayer game by game. Would be so awesome. Yeah, yes. I mean, the idea is I will want to first, I mean, this is a fake cable, okay? Well, it's a real cable, but not a real Game Boy cable, link cable. But the idea for me is first I will implement the Game Boy link cable protocol, so that if I have two Game Boys running as two separate windows, they can communicate with one another. And once I have that protocol running, then I will add a networking layer onto it. And then maybe, just maybe, we should be able to play across the world. I mean, that's a plan. I don't know if that's gonna work, but I think we'll figure out. Okay. Oh, I was saying, there's still one thing missing regarding interrupts, which is this. The effect of EI is delayed by one instruction, which we are not doing this at all. So if I show you, this is setting IME equals to 1 immediately. And it cannot be set immediately, essentially. It needs to be set on the next instruction that runs. So it first runs the next instruction, and only then it sets the IME to 1. So I need to figure out how to do this. I mean, I could do it as simple as I have like a pending IME. Which could be like an option. No, but I mean, this is only for the EI. I mean, this could be a U8. And then I would set this to pending. So instead of setting IME to 1, I would set the pending IME to 1. And then after running the next instruction, I would check if pending IME is 1, then I set pending IME to 0 and IME to 1. Maybe. I don't know. I do not know. But, I mean, at least it's a plan. Doesn't need to be the best plan, but at least it is a plan. So this is EI. So if this sets IME to 1, what I now need to do is, after, the thing is, this execute will set okay, let me think about this for a little bit, because this execute will set pending IME to 1, but I cannot do the check immediately here because I still need to loop this one more time. But I also can't not do the check before, because then it will run before the next instruction. So do I, well, maybe I could do a, instead of pending IME equals to 1, I can do like pending IME equals to 2, and then for each instruction that runs, it decrements by 1, and when it's 0 I set it. Do I like that? No, but it cannot be 0, that's the issue. Because it will be 0 pretty much every time. EI followed by DI does not allow any interrupts between them. Okay. So if I set pending IME to 2, do I need to set it to 3? The hell? This is crazy. No, if I set it to 2, okay, let's imagine how this goes. Okay, so if we execute this instruction, pending IME here will be equals to 2, and what we need to check is if pending IME is greater than 0, and is greater than 0, then we need to decrement it by 1. And then inside, if self.pending IME equals to 0, then we set IME to 1. And then this will be 0. Right, so on the first instruction, this comes as 2, will be decremented to 1. This doesn't happen. So we essentially skip the first instruction that we just executed, which will be EI. And then we get the second instruction, we run the second instruction, pending IME will be 1, we decrement it, it will be 0, and we set self IME to 1. And then we don't ever do this again until we find the pending IME. Maybe? Is this what we want? I don't know. But I think this is gonna work. Let me put a breakpoint here. And we will figure this out together. Okay, so we just ran EI instruction here. So pending IME is equal to 2. And now we skip one instruction ahead. So now we just ran XOR XOR. Good job. And now we set it. Okay, and self IME was set to 0. Now it's going to be set to 1. Okay, I think this works. So, assumingly this works, we can continue now. I think everything that was wrong with the interrupts now should be working. So now everything we have to do is implementing more opcodes. Yay! There are so many of them though. So many of them. Hold on, let me quickly check the other screen. I have an unread message, but I don't know where. Okay, never mind. We keep going. We keep going. So now we will need to implement instruction with the opcode OX34. So it's 34. This one. Good job. And this is a increment by the address pointed by HL. Let's see if this has any weird functionality to it, which sometimes it does. Nope, no weird stuff there. we will need to set these flags. So let's see how this goes. So first things first. We need to add an instruction here. Okay, I need to stop the thing. Okay, OX34, and this is going to be an increment. Well, this is not an increment registry. It's an increment registry pointer. Yeah, it's an increment registry pointer, and this will be with register HL. Good job. So now we need to add this new enum here. Very cool. And now we need to add an implementation of 3D printing to it. So if we were to log this to console, we actually get the full string as it is right here, because it makes it way easier to debug. So it's this really cool. And now we also need to add the number of instructions, or the number of bytes that the instruction takes, which in this case is only one, which is represented by this left value here, this one here. And then the number of clock cycles, which in this case will be 12. And the number of clock cycles is currently being used just to make sure we keep the CPU and the pixel processing unit kinda in sync, so they don't essentially like free run and lock one another with mutexes. Okay, so now we only need to implement the actual instruction for this. So now we go here. This is a register, very nice. Okay, and we need to do self.increment register pointer. We pass the register. Good job. And now for my final trick, we add the method. Okay, and now we need to implement the method. Amazing. Pretty amazing. Okay, how do I wanna do this? So that is the register HL. Okay, so the first thing we can do is make sure that the register is always a 16-bit register, and the 16-bit register is whenever we get two letters like SP, HL, DE, and BC are all 16-bit registers, but if you were to use only A, then A is only 8-bit, obviously. So we need to make sure that whatever register we pass here as an argument will always be a 16-bit register. That's part number one. Now, part number two is reading the actual pointer from that register, which is given by this code. So we go onto the register HL that we are passing as an argument, and we essentially figure out what is inside of them. And this will give us a value pointer, which is a 16-bit value. So now what we need to do is we need to read this value from the memory map. We need to read the value from the memory map. It will be this. And then we will need to increment this value. Okay, so we'll call increment on the old value, and this will give us a new value plus some flags that we can also set onto the CPU. Now, I don't know if we are doing... this is weird. Now, this is the tough part. Okay, this is the tough part. Because, well, not tough, it's just weird. No, actually it isn't weird, because this will be an 8-bit number, and this increment will set the same flags that it's setting for these. Right, so it's setting 0, if it's 0, then it's hardcoding the 0 on n, and then it's calculating that. Never mind, it's all working now. So what we need to do now is we need to write the value back. We need to write the same value, or the incremented value, to the pointer. Good job. And now we need to set flags onto the CPU and make sure that self is mutable here on this function. And if we want, we might as well just put the breakpoint there and see what the hell is going to happen. We wait a little bit. Okay, it stops here on the breakpoint. And first things first, we can confirm that the register that we are getting is HL. We can confirm that H takes a FF and L takes E2. So whenever we read this register, it should be a FFE2 as a single U16 number. Good job, us. Now, what we need to do is we need to read that value from the memory map. And that value is coming up as a 0. Really nice. And now we need to increment that 0, which gets us a 1 and gets us some flags. Really cool. And now we need to write back that 1 that was previously a 0 into the same value pointer that we get from there. Yeah, good job. This works. And now we keep going, and now it's gonna crash on a new instruction. And the new instruction that we'll need to implement is 3C. Good job, us. Good job, us. Okay, 3C is going to be a increment A, which is fairly easy because since we already have support for regular increments, then we'll just need to create the opcode matching, and everything should work pretty automatically, or automagically, how I like to call it. Okay, so we go to 3C, and here, this one, and this will be an increment on register A. Good job, and it's done. We keep going. It boots, we wait, it crashes. D1. D1, it's a pop DE. Okay, I think we already implemented the pop somewhere. Yeah, we already have a pop register for HL, so it means that it will work pretty much automagically for DE as well. So instruction D1, it's a pop register for the register DE, and then because I already implemented the number of bytes for the instruction, the number of clocks and the flags, it already works. So we go ahead. Okay, guys, great news. It booted. Sad news, nothing appears on screen. Hooray! Hell yeah. Yeah, it doesn't work. Which is really, really good because it now means that I have no idea on what we need to do now. My wifey asked me to run some quick errands now. So if you guys don't mind, I will quickly put a be right back of. I will put 3 minutes, but I think it might be. No, hold on. I will put 5 minutes, but I think I'll be here before that. So I'll see you in a bit. Bye bye. Hello, hello everyone. I am back. Back from running errands for the wife. So I think we might as well get started. Well, not started, but restart the Game Boy development. The thing boots, but it doesn't show anything, which means that now we are stuck in some random infinite loop somewhere, which is not ideal. So I don't know what's happening now. So now the fun part begins of debugging something that you don't understand how it works, and hopefully we'll find something that needs to be done. So I added some debugging functionality to the Game Boy. Well, it's not really that much stuff, but essentially I can, hold on, let me restart this. I can pause and resume the Game Boy at will, which is nice, I guess. So now it's like paused forever here. And then I have the ability to click L, and it will print the last, I believe it's 1,000 instructions that it tried to run. Yeah. I don't know if that's going to be useful, but let's see. Well, I don't know if it's 1,000 or 100. I think maybe now it's only 100. But we might need to make it 1,000. No, it's 1,000 instructions. Well, then there you go. But weirdly enough, it's always running the same ones. 26D, 26B, 26C, 26D, 26B, CD, BCD, over and over and over and over and over again. Which is not good news. It means that we are stuck doing something. Ay, ay, ay. Ay, ay, ay. I mean, I don't really know what to try. I can try click L more times to see what changes. So now it is running a different set of instructions, which is cool and all. Which is cool and all, but yeah, I don't know. I mean, it's running the same thing also over 1,000 times. So yeah, very fun, very, very fun. I mean, this is trying to load the value from FF44, which is LY, to the register A, and then it's comparing the value of the register A with OX94, hexadecimal 94, it's 148. So it's trying to do that over and over again, waiting for line 148 in the PPU. And let's see how this compare function works. Compare A with a value, which is the same thing as this. Okay, and the comparison is essentially doing a one minus the other. And then it's saying then it's saying that if the jump, if the number that we get here, so comparison is one minus the other, okay? So if they are equal, we'll have a 1 into the Z register. But if we don't have a 1, which means if they are different, then we'll do a relative jump of OXFA. Okay, and the relative jump just means that we go up or down, because maybe that could be the issue. But I mean, it's trying to run all of these instructions, so it's just going... This is probably a minus 5 bytes or something. Is assigned 8-bit offset. Yeah, so if you have a F here, hold on, a F, no, you have a FA here, can I make this so it shows as a 8-bit, well, not an 8-bit, a negative something? Well, not really, but because the first bit is a 1, we know that is a negative number. And then it needs to be negative all of these bytes here. But I wonder if we are doing this math incorrect. So FN, JR, and Z8. Okay, I think might as well. We need to run it as debugging. Okay, boot succeeded, and now it's doing who the fuck knows. And then we'll have a jump there. Okay, what is our program counter? Is at 216. Uh, 216. Okay, it's always 216 here. I'll just let it run for a little while. Okay, and now we are running on 260, which is where we were before. Okay, and the value that we're getting is a FC. Hold on, wasn't it an FA? Well, then this is something different. FC. Huh. Okay. Now it's FA. Okay. Good job, my guy. Yeah, I wonder if this cast signed thing actually works the way we expect it to. This might be a bug here. How do I check this easily? Well, might as well do a let casted equals this, and then casted I size. Okay. Let's see what this gets us. Because maybe the Gameboy uses two complement, but maybe this does a one complement or the other way around, right? So it will be kind of difficult to figure out actually what the hell is going on there. Okay, but our casted is a -4, and our value was this. Okay, let me hold on. Must be between -7, 128 and 127. Okay, but could offset of -2. Okay, but can you tell me? Can you tell me what is the representation on this guy? Okay, because N8 sometimes is signed, sometimes isn't signed. 8-bit offset. Oh. I think this might be one possible issue. I think I'm treating all numbers as unsigned 8-bit numbers. Okay, I do think this is correct, but I think I'm not handling this E8 stuff properly. 8-bit constant. Is it either signed or unsigned? Bro, that doesn't help at all. But E8 is always a signed number. And we have multiple instructions. Well, not that many, fortunately, but we have 8 instructions that take a signed number. The first one is a JR. Okay, JR takes one. Good. Then we have JR and Z, which was the one that we were looking at, which also takes a I8 instead. And then we have JRZ, which takes a signed one as well. I don't think we have NC yet, so that's fine. I also don't think we have OX38, which is fine. We might have E8. No, we don't have E8. So we are fine there. We for sure don't have F8. Okay, so I think we are actually safe. So that's not it. Good. Then I don't know what the hell is happening. I mean, maybe we are not setting this stat LCD for the VBlank stuff. I mean, there's an interrupt for the... there's an interrupt for the LCD. For this FF41. But I don't know if I'm doing any of these. Because this is set by me on the PPU, which is cool. Then I have FF45, which is LY compare. The Game Boy constantly compares the value of LYC and LY. When both values are identical, LYC and LY are identical. Okay, what the hell is LYC then? Do I even have a LYC here? Or do I write here? Ah, okay, so I might write the value here to FF45, and then whenever LY equals this, when both values are identical, the LYC equals LY flag in the stat register is set, and if enabled, a stat interrupt is requested. Ah, then maybe that is what's missing here. Maybe that's what's missing here, because I don't think I ever use stat for anything. Yeah. When both values are identical, the LYC equals LY is set, and if enabled, a stat interrupt is requested. If set sets this, damn. Okay, are we actually getting any write to FF41? Because that's probably the easiest part. Like, are we actually getting a write here? Yes, we're getting a write here. Value of 0. Well, then that is completely useless, isn't it? This is just disabling everything. I mean, this is only setting a value of 0 there. Two to 9. Okay, what is the instruction that we are trying to run? LDH 8 pointer register A. So we are trying to copy the value from register A, which is a 0, into that value, which is 41. That starts as the nav, so it's FF41. So we are writing a 0 there. I mean, that's all cool and all, but kind of useless. I mean, this just disables everything. If set, if set, if set, if set. Set when ly. Okay, so then I have a question. Greetings, Simonot. Hello, good morning. And welcome to a new week of amazing game development here on stream. How was your weekend? Yeah, we are having issues. We are having tons of issues with the Game Boy. It boots and nothing shows. And I don't know why. Amazing stuff. Amazing stuff. Yeah. My current question is if set, that's the interrupt. Well, artwork work in the monochrome Game Boy makes the LCD interrupt sometimes trigger when writing to stat, including writer 0 during OAM scan, H blank, V blank, or LYLC. Okay, but it is sometimes trigger. Okay. But yeah, I'm trying to figure out what the hell is going on here. I'm trying to figure out if we actually I don't even know. But for example, here I'm getting an instruction that should write 0 to this FF41 address, which is this LCD status. But these are read and writes, but these are read-onlys, because supposedly these are being set by the PPU and not the CPU. So if I'm getting a 0 here, should I not write these ones? Maybe. Because this is the game code running. So I don't think they should be setting this. So what I can do is let value equals, then I can match on the index, and then I can do fun stuff like if the index is that, then the value will be value and OX F so this is a 128 there's more. Okay, so it's -3 -3. So instead of FE, which is the last one, right? No, FF is the last one. I need to go back 3. So it's 1, 2, 3, FC. And this should discard the last 2 bits. Good morning, Lit Geek. Hello, hello. I need help. I don't know what the hell I'm doing. I don't know what the hell I'm doing. I mean, I could even do a... this. like a bit mask, where I essentially discard the first two ones, which are these ones, because they are read only. Ay ay ay. I mean, this won't solve for anything, I guess. How was everyone's weekend? Plenty of birthdays, and plenty of Easter celebrations, and plenty of food and wine. It was glorious. Glorious. What about yours? Ate my Easter egg. I have a half-eaten Easter bunny here. Chocolate bunny. But yeah, also plenty of chocolates and almonds, and went to visit family and celebrated Easter. Yeah, man, that's nice. I really enjoy, like, not because it's a religious holiday, but just because I get to hang out with family and eat amazing grandma food, which is like the best thing in the world. Okay. So I need to do this. And this probably is the PPU that sets this. Isn't there an LCD control which LCDC, which is this one? This already tells me if the PPU is enabled or not. I mean, my only theory is that we are not handling interrupts properly. That's my current theory. But I can also check if we are reading from FF41, like the value of the of that register. But we are never reading from there. Yeah, I have no idea what's happening. I have no idea. Yeah, I mean, once the boot ROM finishes, it never reads from the boot ROM anymore. Then it always reads from the game. I mean, let's try and at least make this stat thing work here on the LCD, on the stat register from the PPU. Maybe it will work, maybe it won't. I have no idea. This code is way more difficult now. Okay, so here I write ly. is this past the point where it was erroring button implemented instructions? Yes. And I also did some fixing to the, I can show you the code. I also did some fixing for the stuff that wasn't working properly. Well, I already added a bunch of stuff, didn't I? Oh, I forgot to push Friday's work. Okay, hold on. Hold on. Let me quickly do this. Add ink. Okay, this one we did today. Ay. I mean, it's not that relevant, but this we did today. I think we only did like 2 or 3, actually. But we added this pending IDE. We added this pending IDE. You can ignore. Oh, I lost the. I forgot to commit. Can I still do this? Hold on. Okay, I think I might need to roll back everything. And hopefully it's going to be near what I wanted. Does this have a pending IME? Fucking hell. Okay, cool. We lost 1 day of commits. Well, it's just a single commit, but I wanted to like keep track of how much work I did per day, and now I lost it. Undo buffer 999. Well, now it's a little bit too late for this, but undo transparent. Terminal, scroll back buffer. Okay. I need to check the size of the buffer on JetBrains IDE. And do buffer. Local history. Bro, if you have a copy of it, I'll be your best friend forever. Please. Yes. Okay. They actually saved the freaking file a billion times. Okay. So, I mean, it's so freaking stupid. Okay, day 6. Oh my god, it's already unselected. Bro, stop. Okay, I want to go to the first entry of today. Which in theory is this one. Okay, which is this one. Can I select two of them and see what changed. Okay, cool. 34. Okay, 34 was the last one. Okay, do I have a 34 here? I do, so I want this one. Good job. Good job, us. How do I do this? Like so. Okay. Sorry guys, I know this is boring, but I need to do this. I need to do this. Okay, this is done certainly. This is also done. This is also correct. On the memory map, I need to unstage this and this. All of this goes. On math, we didn't change a thing. On main, we didn't change a thing. And on GUI, we didn't change a thing. Okay. And this is day 12. Good job. And now this is what we did today. Hooray! Good job. We did it. We did it. Okay, let me read. Every time I install Blender, I regret not doing that. I had no idea this was a feature in Rider. Me neither, but I'm very grateful it is. I mean, it has all of the code, which is actually cool because, like, it even has since the file was created. Which, if you remember, you told me that it would be cool if I could like show the code generating, like for a YouTube videos or something. And maybe this will allow that because they have all of the files, so I can literally see like line by line how the code was constructed, which might be like a cool visualization thing. Yeah, very cool, very cool. It doesn't have a retention period and won't survive Rider updates. Maybe worth upping it. How? Let's see. Settings. Local history. Duration of storage changes in local history. 5 days. That is not true at all. This is not true at all. Today is the 6th of April. And this goes all the way to March the 17th. Well, it's at least 2 weeks of... No, this is actually the thing. Well, it's saying it's only 7 days, 5 days, but they're lying because they be lying. The hell? Local history. I was writing file history. Local history. says 5 days. I mean, might as well put half a year. I mean, these are only text files, so these are fairly tiny. Although, we'll see. But I do have an update here. I have no idea. Okay, we keep going. This does this, and now it's stuck. And it's stuck on around the same instructions as it was before, where it tries to do something a handful of times. And I don't know what's doing. I don't know what's the issue now. But in any case, I don't know if it is what I need to do, but what I will do is writing these lyc equals ly and this PPU mode there. Maybe these will do anything. Okay, so here I need to do a stat, but stat is an FF41. Okay, so I need to do a stat address 41. So here I'll need to do it's a read memory map. Is going to be stat address. This is going to be a stat. I mean, I could literally do the other thing, but whatever. And then here I'll do a set bit stats 00. Mutable. Okay. So this grabs the value from the memory map. It sets the bit 0 to a value of 0 because this is disabled. And I need to write to the memory map the new value. Good job, me. And here I need to write a value of 1 because the PPU mode. Oh no, PPU's current status. Huh? Oh no, hold on. So this is actually hold on. So this is actually 2 bits. It goes from 0, 1, 2, and 3 depending on the PPU mode that we are currently on. I see. But first, here on the right memory map, this is actually 3 bits. Right, so it's 1, 2, 3. So both for PPU mode, one for LYLC, and then it's 1, 2, 3, 4 for the 4 int selects, and then 7, which is a no op. No one cares about 7. Okay, so that part there is done. But now Okay, so this is not actually here. I'll need to do the current mode that I'm currently in. Oh man, I don't like this code at all. This clock simulation thing between CPU and PPU. So mode 2 is OEM scan. So when I enter mode 2, I do an OEM scan. No, this is only for the transitions part. Okay, then what I can do is I only need to set this at each transition. So I did mode 2 and now I'm transitioned to mode 3. Okay. So what I need to do here is I'll need to get the mode, my current mode, self.state. I mean, might as well do a 2 bits something, and then HL, something like this, and FN 2 bits. No, this needs to be a U8. U8, U8. And then here I match self. And if it's 0, 1, 2, and 3, 1, 2, and 3, 1, 2, 3. Okay. Okay, and this is going to be the value of H, this is going to be the value of L. Okay, and this sets the PPU mode on this stat register. Good. Now I need to set that one. Now I need to set that one. So I'll need to write. Do I even have LYC like this? No. I mean, I do have the register, but I don't think I have the method to read it. It's whatever. It's whatever. So I'll do a let LYC equals LYC. I don't need the SU8 because this is already a U8. LYC address. Okay. Set when ly contains the same value as well as c. It is constantly updated. Okay. So if lyc equals, do I have the current line? No, I have this y there. Ly. I mean, might as well put it outside. No, this will be off by one. Well, off by one clock cycle. I mean, I can just read it there, my guy. It's whatever's. So I read lyc, I read ly, and then I do if lyc equals ly, we will need to set bit number 2 to 1. Okay, and here we do if lyc equals ly, it's a 1, else it's a 0, and this now works for everyone. Good job, us. Good job, us. Stat interrupt. There are various sources which can trigger this interrupt work occur. The various stat interrupt sources, modes 0, 2, and ly equals lyc equals ly have their state logically ORed into a shared stat interrupt line. What the hell does this mean? A stat interrupt will be triggered by a rising edge transition from low to high on the stat interrupt line. I mean, if you say so. The various stat interrupt sources have their state logically ORed into a shared stat interrupt line if their respective enable bit is turned on. Okay, so I have this, and then I'll need to check if mode 0 selects this, if mode 1 selects this, if mode... Okay, but are these stat ones automatically triggered by me and not by the... No, I mean, the cartridge should set this, but it's writing a 0 here. So if it's writing a 0, it's just saying that it doesn't care about any interrupts for so far. If interrupts are enabled for 2 consecutive modes, such as mode 1 and mode 0 and mode 1, then no interrupt will trigger for mode 1, since the stat interrupt line won't have a chance to go low between them. Okay, so I need to keep track of the previous state of stat. Okay. Well, I have no idea. I have no idea. Key I mean, I tried to add some debugging for interrupts. But What values are these? Something is messy here. I wonder if there's some instruction that is doing something that it shouldn't, and that's what's causing all of this. Because it's so possible. It's so possible. Yeah, I do not know. Very fun. I do not know. I mean, these didn't do anything. So, what can I do to try and figure out what the hell is happening? I mean, I can click L and that will log me the last 1,000 instructions, but this is not that useful because it's running the same 3 instructions a bunch of times. Did I mess up the length of any instruction in terms of bytes? It can be so much things that are wrong right now. What can I do? I mean, I do know they have some test ROMs, so I wonder if I should try and use those just to see what the hell is gonna happen. Thoughts? What would you guys do? I mean, I have no idea. Is there anything that I'm missing in the cartridge? I mean, there's the cartridge error, but I don't think I care for any of this. RAM, ROM. MBCs. No, but the reason I'm using Tetris is because I know they do not have memory banks. Hello, Ducito. Welcome to the stream. Well, I've seen you here before, but it is your first message. I will do what I did as a kid and check the answer sheet, which would mean asking AI today. I mean, I'm trying as most as possible to avoid LLM, at least for this project. Doesn't mean I haven't used it. I mean, I did ask ChatGPT to verify if my interrupt code was working, and that's why it told me that something wrong. There was something wrong with it, and I fixed it today. But yeah, now it's not working, and I have no clue why. Maybe if I could find. Okay, so essentially, I'm trying to do this the old school way as much as possible. Let's start with that. I'm trying not to take like any shortcuts or anything. I'm trying to read the reference and these tables and plus this reference and do stuff that way. And if possible, I can use tools that they had at their disposal to try and figure out what the hell is happening. Yeah, in my humble opinion, it's the best way to learn. I'm just becoming lazy. Yeah. I mean, I don't use LLMs at all to code for me because I do enjoy coding. I mean, that's the best part of it for me. But every once in a while, I do ask the Mr. ChatGPT what they think about something, for sure. I mean, I do vibe code some apps every once in a while, but mostly small web pages, small dashboards that I don't want or care about implementing myself because I hate web development. So those kinds of tasks I relay to Mr. ChatGPT, but everything else I try to do it myself. At least the emulator, because I've been wanting to do this for so long that if I were to do this 10 years ago, then I would have no AI, so might as well try to go through what my 10 years ago Dudezord would suffer with. And currently the suffering is the game boots, which is cool. Tetris is trying to boot, but now it's stuck running some instructions over and over again. And I don't know why. I don't know why. I mean, I could try and disassemble Tetris on my own. Why not? I mean, why not? It's all here. Yeah. But as I was saying, I know that there are some test ROMs that someone developed. And these ROMs, if I can find it, testing. Yeah, there's these test ROMs which essentially try to validate if the functionality that you currently have is working or not. The thing is, I haven't validated or I haven't implemented all of the instructions yet. So there's these CPU instructions here. but I don't know what is going to happen there, because it's probably trying to validate all single CPU instructions that I don't have yet implemented. But I mean, if I don't have them implemented, I might as well just skip ahead instead of crashing. I mean, it's a possibility. YOLO. Source. Individual. Special. Op. Nah, let's do all of it. Okay. Let's YOLO test this. But I mean, I don't even have I'm not even like rendering anything to the screen. So this will be mostly useless. Ay, ay, ay. Yeah, I don't know. I do not know. What the hell is this? MTS. Same suite. Same suite. A suite of Gameboy tests used for hardware research and emulator testing. Okay. I mean, I don't know if I want to do this. I mean, I'm not even able to render this. Okay. What do I want to do here? I think I'll do a 5-minute break because I do need again to go to run some errands for wife, which will take like 3 or 4 minutes. So I'll see you in a little bit, and maybe it will unlock something in my brain of what we should be doing next. So I'll see you guys in a few. Be right back. Olá, olá. I am back. And I still don't have an answer. And I still don't have an answer. I mean, if anything, we need more debugging functionality implemented. Right? That's maybe what I would say it's our issue. But what do I actually need to implement here? What do I actually need to do here? Yeah, I mean, the issue is I don't know where we are stuck. I don't know where we are stuck. I thought that the interrupt would essentially unblock us, but that's not what's happening. Can I find the disassembled Tetris without interrupts? No. I want the original Game Boy Tetris, but disassembled. Yeah, disassembly. Yeah. It doesn't build yet. A comprehensive disassembly of Game Boy game Tetris. I mean, yes. Well, it's this version, which I don't think it's our version, but might as well be similar. Maybe. I kinda just wanna know what the hell we're going wrong with this. Like, what's making us be stuck into an endless loop? Yeah. Do any of you have any suggestion? I mean, if we are legit stuck, I can vibe code an answer. It isn't ideal, but I think it will make us move a little bit faster. What more is here? Do we ever write to ecoram? I mean, that's one random thought. That is one random thought. If index is greater or equals than E000 and less than FDFF. Because essentially these reads or writes here should write to the regular RAM. And we do not. So that's not the issue. Jump vectors. Being lazy used to be the pride of programmers, now it's shunned upon. Yep. That's why I'm trying to avoid it as much as possible. But I mean, it's fairly difficult now to figure out what the hell the issue is, because I'll essentially need to revalidate all of this just to make sure that it's not a CPU instruction, or I can one-shot say, Mr. GPT, can you tell me if there's something wrong with my instructions? A full verification. Well, full verification is writing unit tests. That's what the full verification means. Otherwise, it just explodes and stops randomly. Yeah. Yeah, I would say that's... I mean, I legit do not know. I mean, it could be trying to start the sound, and because we don't have sound, then the game doesn't start. It can be one instruction that is wrong. It can be having some weird issue with the rendering, although not rendering at all means that it's getting stuck prior to that, because it should render something now. I'm pretty certain. Maybe. Okay. Okay, let's... What happens if we try to run Super Mario? I mean, maybe it will show something. GG, it crashed because now it's an instruction that it doesn't support. Ay. Although the boot ROM rendered okay. Yeah, well, but we have 3 layers. We have the background layer, which is what the boot ROM uses. But then we have a window, which is a secondary background rendered in front of the background. And then we have the objects. But as far as I can tell, we don't have any objects yet. I'm gonna bet on a timing issue. I mean, it's fairly possible, because when HL, well, I kinda needed to figure out what the hell was at HL there. But for instance here, this part of code that is running, it's loading the value of memory address FF44, which is the current line that you're rendering, into the register A. Then it's comparing that value with the hexadecimal value for 94, which is 140 something. So this is trying to figure out, okay, did I finish rendering that that screen? Is this cheating? That's what I was talking about prior. I have test ROMs here. Where? Somewhere here. Where are you, bro? Yeah, I have like test ROMs here. The thing is, the test ROMs assume that you have all of the instructions implemented. Because if not, it will just keep crashing and crashing and crashing. Because they try to run. Yeah, it's this. Although yours is on a GitHub. This is what I thought about running, but I don't know. I legit do not know. I mean, there's these CPU instructions. I mean, I already downloaded it, but this guy has like individual stuff and interrupts and whatnot. I mean, maybe this can be the... We can try. We can try. Open in Explorer, ROMs, new folder. Who's this guy? It's Blar GG. Blar GG. GB tests. Blar GG tests, and this will be O1 special. I don't know what the hell this O1 special does, but it's probably gonna crash because it doesn't have one instruction. See, it doesn't have instruction 12. So this will just force me to implement a bunch of instructions. The interrupts one now crashes on 12 as well. Yeah, so this will just force me to implement everything. Which, meh. I mean, that's probably what I need to do, actually. Maybe that's the way to go. Like, implement all of these all at once. Wondering if the annoying work of implementing them all is required to help validate it. I would say so. I would say so. I mean, how many do we have written now? 114 minus 26. So we have 88 out of 256 here. And we are not even counting the prefixed ones. So yeah. I mean, these are mostly just copy pastes, like adds, subs, and zens. So maybe I should just go. But what I wanted to do is, okay, at least if we are able to show the start menu for Tetris, then okay, we are able to boot a game. Not play it, but we are able to boot a game. So let's just tackle all of the instructions. But the issue is I don't need to make any of these instructions work because the game is not requesting any more instructions for now. So yeah, I don't know. This guy is just stuck. And sometimes it unstucks itself. Right, so here it's trying to wait for a a screen render, and if the screen hasn't rendered, then it goes to jumps like 4 or 5 bytes and like retries again. If not, continue. So maybe what we can check is what the hell is that 238 OX 238 and OX 238, it's a FA. Okay, hold on. Maybe we need to run this thing almost manually, you know? And see what the hell happens. Because I don't see a better way now. If self.pc equals 023 J, R, and Z, this is a 1 byte, so this is 2 bytes, this is a 39. Or, yeah, I think this will be at 39. Admit A equals 0, A equals 1. Good job. Okay, this should run probably twice, one for this, and then one this. Okay. Okay, so this should be running immediately after that as the screen rendered instruction. So what the hell is this trying to do? Do we have an interrupt? We do not have an interrupt. So we will be trying to execute instructions now. So our instruction is load a number into register A. I mean, that's fairly easy. What is the value in A though? A as 148, which is the number of the line that you are currently in. And then we are loading that value into an 8 pointer. So our value is currently 40, so we are going into FF40 and loading the value (64) there. Okay. We'll figure it out. Slow and steady. Okay. So we are going to this LCDC control and we are writing the value of A, which is 3. Yeah, we are writing the value of A which is 3 here. So it's enabling objects. Oh. Okay. So it's actually rendering objects. So all of that text is objects, and that's why it's not rendering them. Well, maybe. Okay, so let me check something now. If I go to OEM scan, which is here, objects enable equals 0. Do we ever get here? No, see, like we don't get here. This is supposed to be set to 1, LCDC, FF40, but we don't ever get here. So yeah, that would seem that it's a timing issue. But why? What part of the thing is not timing properly? Okay, so this is writing the value 3 to register A. Yes. And then this is copying the value of the register A into FF40. So this will put a 3 here, but the 3 here will be these ones. Now, is this function messed up? I mean, it's possible. Okay, so the value pointer is 40. The register is Z. FF40. The value is 3. And then I'm writing it into FF40, that value. But FF40. Well, then it's writing the value. Then it's writing the value of A into 47. FF47. Background palette. Okay. And the value of A is E4 228. Which is these colors, which sounds good enough. And then it's trying to copy the value from A, which is 228 or E4 into register FF48. Object palette. And then it's writing a value which is C4 into register A. So C4 goes into A. And then it also tries to copy that C4 into FF49, which is that. So object palette stuff still. And then this stuff. And then it writes FF26 into HL, FF26 into HL, and then it writes a value to A, which will be 80, FF26. Okay. FF26 is sound on, sound off. So it tries to do something with the sound. LDD reg pointer reg. So it's an LD with decrement. Okay, so A is 128. Reg pointer HL points to FF26. Okay, so it's gonna write 128 to FF. Hold on. FF26. She's sound on, sound off, so it's gonna write 128, which is setting the audio on. And then it's gonna decrement the value of HL. So HL won't be FF26, it's going to be FF25. FF25. Artemis flyby today. Yeah. Do we have a ETA on that? I mean, if it happens during stream, I might as well pull it up. Then it loads an FF into A. And then we are on FF25. Sound panning. Register pointer. Okay. And then FF24 master volume, and it sets the value 119. Then it stores a new value into A. Which is 1. Then it OX 2000. Well, this is RAM now. No. There's something wrong here. It's going to try to read the value from register A. Into ROM 2000. But you shouldn't be able to write there. Usually well, no. But it's a ROM, you cannot write there. Is this the issue? It's like trying to... You shouldn't ever be able to write under 7F. So I wonder if I'm parsing something incorrectly. Or is it an offset above this? Maybe it's like 2000 after 8. So it's like on A. Maybe. So this is a load. Load 16 pointer register A. Copy the value in register A into the byte at address N16. Well, the issue is that the byte at 16 is ROM. So what the fuck do you mean? My Stream Deck is the correct orientation now, fixed itself. Well, congratulations! Hooray! Yeah, that was a weird one. That was a weird one. I mean, it doesn't have a... No, because it wasn't rotated. It was like flipped. Well, yeah, then I wonder if it was some sort of April Fool's prank or something. Okay, this is a problem. It's gonna try to write this into ROM. This is ROM. Read only. So you cannot do this. Let's try to validate this. Right. If index is below 0x7 FF, I mean, it should never write there. And it's not writing there. Huh? Then what the hell is that instruction? Oh. 7 FFF. Yep. It shouldn't be doing this. So we are doing something wrong with our jumps or the length of the instructions. For fuck's sake, bro. Ay, ay, ay. Okay, we found an issue. We found an issue. Okay, now the issue the issue with this issue is how do we figure out what we need to do? I mean, obviously this instruction shouldn't ever happen. So it's trying to get the value from A into 2000, but I cannot do that. I cannot write there. program counter 254. EA. EA. A16. Is this an offset though? Means Little Indian, 16-bit. I mean, Little Indian just means that the first byte is the little one, so it's 2000, right? But I don't know if I should be here. I don't know if this is part of the cartridge header or not. Which I think it is. So what the fuck are we doing? Okay, it's not part of the cartridge header, it seems. No, hold on. I'm already confused again. So the instruction that we're getting is we are trying to write to byte 2000 the value on register A, and register A is 1, and we are trying to write to 2000, right? And the program counter is currently at 254. The program counter is currently at 254. How do we get up here? There's something wrong. There's something wrong. I just don't know what. What do I do now? I mean, what would happen? Should I mean, I don't even know how to put this. But do we know if writing to a read-only is a valid instruction? I mean, it's read-only, so obviously you won't be able to write. The thing is this considered a no-op? Or it's a bug we have and we should crash? Disassembly, compile 1.1. Palettes, constants. Okay. The assembly of Tetris for the Game Boy. Okay, these are the interrupt vectors. But I mean, I don't know if this is actually the same order. Load. I mean, there. I mean, 2000 is this. So I wonder if we are probably parsing something wrongly here. Nine FFF. I don't have anything here. Ay ay ay. E20. Zero zero 20 20. Well, I have a 0020 here, and then it's a it's the. It's not this one. Ay ay ay. Why does this need to be so difficult? Load HL. Okay. What happened if I were to just skip? Okay. I mean, okay, it skipped ahead, but why would this happen? Yeah, I mean, I need. I don't know what to do. I don't know what to do. It's amazing. Because it can either be the length of the instructions, it can either be the returns that are returning to the wrong point, it can either be the jumps, it can be the calls, it can be so much shit. What kind of debugging tool I could write now that would help me? What could I write now that would help me? That's the important part. This is not clocks, this is cycles. I mean, I think I'll need to. Okay, I'll first start with making sure that all the lengths are proper, because that might be the issue. I don't even know. Like, where do we get even a prefix here? Okay, so we get enough prefixes just to unroll the bootrom logo. Where am I? Self PC. Instruction 8. Okay, so here we already did something. Okay, so length is always 2. Okay, so this is a prefix of a swap A. And program counter is at 29B5. Holy. 29 B5. CB37. CB37. Okay, but it should jump to 30 something. Fuck. Found it. Found it. For fuck's sake, bruh. Found the issue. Or one initial issue. No, I mean, it shouldn't matter at all. Because when I'm gonna call that, I won't ever use that. No, never mind. I think. Never mind. Okay, hold on. This was a bit 7H. Bit 7H. I mean, here it will try to read the value. But why did this skip? Oh, I didn't enter. I see. Yeah, I wonder if I'm not setting flags properly as well. I mean, Must be there are so many possible issues now. Okay, but length will be 2. And you're currently on byte 8, which is this. So it's gonna jump to byte A on the self PC. Yeah, okay. So that's not the issue. Okay, we keep going. No op 1. Decrement is always 1 byte. Okay. Ink are always 1 byte. Size wise. Loads. Okay. Here they are all 1. This is a reg pointer, which is different. And this is a load reg 8. I mean, it's fairly straightforward. This needs to be 2, this needs to be 3. These are hard coded. This is 1, this is 1. This is fine. These are hard coded are 1, 1, 2, 1, 2, 1, 1, 1, 1. JR8 needs to be 2. And Z 1, 1, 1, 3, 1, 3, 2, 2, 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, 1, 3, 1, 1. Yeah. Okay, so the links for the instructions are correct. So that's that part is easy. So it's not this. How could I kinda wanted to write like the entire path for the stack trace where so instead of pushing the last instructions. Okay, so let me try to explain. So currently when I click on L, it prints like the last instructions an awful amount of times. Loads, ORs, blah 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 blah. I mean, this looks proper, kinda, but if I were to select this part here, hold on, A0, A1, BD, and E9, F, and then goes back to A0. Why? Oh no, because 9 is the smaller. Okay. So this instruction is looping a bunch of times. This one is looping a bunch of times. And what I wanted to do is, instead of printing these 500 times or whatever, I wanted to say like, okay, these ran X times. And then I would display the other and then I would display the rest of the call stack. Okay, I don't think I'm explaining myself properly, but but essentially I don't want these logged a bazillion times as it is right now. I want this logged once, but saying this block here ran for X amount of times before it continued to A3 or A4 or something. You know? But how can I do that? Because this is stuck and this is running millions of instructions each second, but it's only running the same 20 or 30. But the way that I can do this is whenever I get this F8, I already knows it means it's gonna start from there. So if I do jump, so whenever the first time I do this, I already know that if I do this jump, then it's because I am on a loop. Yeah, I don't know. I don't know. I wonder if it's the bit flags or something. But that would mean that I would essentially need to build unit tests for all of this, which is probably what I should be doing. CPU debugger next. Yeah. CPU debugger next. But what do I want to use with Rust to build this? Because at the same time I don't want to be rendering windows with text on my own, you know? I consider going the not EM GUI because that's not really compatible with Rust, but there are other ones like eGUI. And I mean, these ones are really cool. This one. There's like a bunch of stuff. And if I were to use these, then I could have like all the debugging stuff that I would need. I don't know. The issue with this is that this renders the entire, I think this renders the entire layout every time. Let's see, like, even if I move the mouse 1 pixel, it renders the entire thing. And if I were to have this screen rendering, then it will essentially call this every single time, which is not that bad. I mean, this works fairly quickly and it renders the entire thing in only 1 millisecond. But I don't know, man. Is this what I want for my life? Maybe. I mean, it renders pretty fast. Okay, should we plug a GUI with this? Because then we'll have access to cool stuff. For as example, miscellaneous demos, no. UI stack precise, checkboxes, no. I mean, then there are like memory editors and stuff inside. Do you know what you want to debug specifically? Is a GUI even useful for that? I mean, I could have a live view into the tiles, so at least I could see if the tiles were rendering loaded properly. I could have the tiles, and I could have like the entire, not the LCD, but the entire region. Because essentially you have a larger screen of 256 by 256, like a square, one point. So you have a large 256 by 256 pixels here inside, and you render tiles here, and each tile will be an 8 by 8 thing, and tiles are always written like all at once. There's no possibility of rendering off tiles. But then inside these you have a smaller 160 by 144 rectangle, which is the actual thing that gets put on the LCD. So I could have one screen rendering this entire tile map of 256 pixels by 256 pixels, and then I could display a rectangle inside that would show me what the hell is supposed to appear on the Game Boy. And then I could do this for the background and for the objects. But in this specific case where I'm currently at right now, I don't know if it would be useful. Because the issue is, I don't know what's wrong. I mean, I have one theory, right? The theory is we shouldn't be writing to this address here ever, because this is ROM. So why are we trying to write onto address 2000 if 2000 is ROM? So that means that there's something wrong elsewhere, and I don't think we'll be able to figure out what until we do like a proper pass on all of the instructions, making sure that all of the flags are being properly set, and all of that shit. Like how it maps the card into memory. I mean, this address is invalid no matter what, but essentially, whenever you are reading from the memory map, we are keeping track if we are booting on or not, and booting is specified by this flag FF50. And if we are reading below 100, we check if we are reading from the boot ROM. And if this value is 0, we return the boot ROM. If this value is 1, or we are reading below 7 Fs, then it's always the game ROM, the game cartridge. But the cartridge is mapped all the way up to 7F. The RAM only starts at 8000. So we are trying to write, this is a write, to 2000. But now the question is this a valid, is this an operation that I should try to execute, but because it's an invalid operation I just skip ahead? Or does this mean that I'm doing something wrong? And I would say that I'm probably doing something wrong. Maybe, probably. But it's fairly difficult to understand where that issue might come from. Okay, I think I'll go for another 15 minutes and then I'll do a 30-minute break and then we'll do some more game development in the afternoon. We have a new game to kick off today. But yeah, we have 15 minutes to try to come up with a plan. So if there's someone else watching the stream that has any idea of what we could try, I would seriously appreciate it. But as of now, I think I'll need to double check everything. I mean, I think I'll need to double check everything. Which is already a ton of stuff to do, actually. Because I don't think... Yeah, it feels like a mapping wrench is wrong somehow. I mean, it's not the mapping range that is wrong. This mapping here is... How do I say this? I wouldn't say that the issue is the memory map. The issue is one specific instruction that has a bug. Like a jump instruction that it's not properly calculating the address that it needs to jump to, or when we return from a call method, we are not returning to the proper address, so it gets like offset by 1 and then it essentially starts running garbage after. But I mean, hold on, if I'm here running this, could I now pause? Because essentially I know that this is wrong, so I want to know what ran before this. So how can I do that? can I pause this somehow? Like here I have pause equals false. Could I set this to true from here? If I could like whoops. I mean, I do have the last instructions right here, but this is kind of meh. It's kind of yucky. So what can I do instead? Could I grab the program counter and maybe do that? If self.pc equals 0x0254, then we self.log last instructions or something. It's something like this. I essentially need to log stuff. Found for mutable CPU. What do you mean? Print. Good job. Yeah, I think I essentially want to print this. And see what the hell happens, you know? See, like it's printing garbage. Because it's trying to... Okay, where is my... No. Okay, so it's running 235, 237, 233. Okay, so it's running 233, 235, 237. A bunch of times. A bunch. I'm scrolling, even though it might not look like. It's running the same thing like 300 times. It's going. And then, after a while, it jumps to this one. Right? Right. Jumps to this one. So here, it properly rendered that frame. So it jumps here. And now, it loads the number 3 into FF40, which is enabling objects and background stuff. FA. No, sorry, I was reading the wrong thing. Okay, then it writes OXE4, which is this, to FF40. Sorry, FF47, which is the background color palette. FF47, which is this. And then it does the same thing for FF48. And FF48 is the object palette. So background palette and object palette have the same color. And then it writes C4 to A. So instead of E4, it's C4 to A. This looks proper. To FF49, which is the second object palette. Okay, so far so good. And then it checks wherever is in FF26. Oh, it checks if the sound is on. or it reads this byte and puts it into HL. Sound on off. Hold on. This is fairly difficult. Sounds like a good lead. Very funny. Good job, Simonot. I'm desperating right now. Okay, so it copies whatever values in FF26 and copies it to register HL. Then it writes 80 into register A. Then it copies 80 or 128, which is audio 1, I'm not, I don't think this instruction is correct, because here it shouldn't have these square brackets here. It should be the value FF26 is not, and not the memory. So I wonder if this is the issue. $247. Go up, all the way up we go. Can I even zoom here? Meh, not really. To what? 247. 247, it's this. So it's a 21 opcode. Okay, 21 opcode, it's this. The load HL and 16. Okay, let's see what the hell is I mean, maybe it can be just the printing that is wrong, okay? But we'll see. OX21. OX21. Okay, it's just loading 16 bits into the register. Okay, so this is proper. Just the printing is weird. If I add to guess, yeah, just the printing is a little bit off. Okay, but okay, it writes 80. It writes 80 into FF26 and then it decrements to FF25, which is sound panning, and it writes FF there to this. Okay, so it turns all of them on, but then it decreases to FF24. No, hold on. Okay, so writes 80 here, writes FF here, and then it writes 77 to HL. Okay, so then writes 77 here to volume. Okay. Is your sound on in the emulator? I guess so, if it's continuing to set up volume, etc. I don't have any audio implementation at all. But I mean, this is just reading and writing from memory, so I wouldn't expect anything. I don't know. Then it writes a 1 into A, and then A into 2000. I mean, This doesn't make sense. But so far, these instructions look legit. These instructions look legit, but this instruction here is weird as F. But maybe if I get one of these, maybe I need to offset by 2000 based on the ROM. I don't know, it's weird. Because I cannot modify the ROM, that I know for sure. But in any case, hold on. Maybe this instruction might have the wrong length. 250. 250 is 36. 36 is load edge L and 8. Okay. And it has a size of 2, so it goes from 250 to 252. And then it loads 1 into A, and then it's 254. So it runs this, and then it loads 1 into A, and then it runs this, EA. 254 is EA. And EA Sports, it's in the game. Got him. Loads A into this, but this is an invalid address. Okay. ROM bank switching. Writing a value to this range tells the cartridge which ROM bank to map into memory. But, okay. I appreciate that. That makes more sense. The exact reason why I chose Tetris is because I was assured that it wouldn't have multiple ROM banks. Okay, so this is something that we now need to handle. Okay. Oh my god. Hold on. As the Game Boy offers blah blah blah, timing. Okay, how do I know? Small games of not more than 32 kilobyte ROMs do not require a memory bank controller. For ROM banking, the ROM is directly mapped to 00 to 7Fs. Tetris, 32 kilobytes. I mean, this is the specific reason why I chose Tetris, you know? But maybe I've been bamboozled because it's obviously trying to read this. But this is the first chip for the Game Boy. Yeah, I think we will stop here. Unless this should modify the mapping, as in now it maps a region, a different region into a different one. I mean, this is even difficult to understand. In each cartridge, the required or preferred memory bank type should be specified in the byte 147 of the ROM. (147) cartridge type. Okay. 147, 147, 147, 147. Wow, it's 0. Amazing. So it's a ROM only. So this should be a no-op. This should be a no-op. But this doesn't mean that there aren't different stuff here. RAM bank is selected. Well, but maybe I have like additional RAM. No, because this should all be the same. No, oh wait, it should be with an additional RAM. I don't know. But it's 0, so in this case the ROM gets mapped in, and 2000 is the range of the cartridge, and that's where it is read-only. I mean, it will always be read-only. That part will always be read-only, no matter what. But that only selects the part of... Okay, hold on. So essentially you can have N ROMs, N ROM chips. Okay, because each chip is only... I don't know how much this is. But like 16 kilobits. Yeah, each chip is only 16 kilobits. And you might have multiple chips in case you want to have a more complex game, like Pokemon. Pokemon is a 2 megabyte game. Okay, while Tetris is a 32 kilobytes game. So you need to load ROM banks in and out so you can like grab different data from different parts of the ROM. But this is always read-only, for the exception of address 2000 apparently, where it will map which ROM is actually mapped here. Switchable via a mapper, which I guess is what that thing does. But in any case, this is the first ship. No, but we don't have this, we have the regular one. no banking. So in no, okay. No, but yeah, it's a regular memory address, but this is a write, you know. So this is writing 1 there, but this is read only. So 1, I don't think it should write. And then, yeah, I don't know. Okay, this is ROM bank read only, which is ROM bank 0. But you can have optional RAM, but I don't think you have optional RAM. Unless this is putting more RAM into the thing. Optionally, up to 8 kilobits of RAM could be connected at A00BFF using a discrete logic decoder. From what I'm googling, it's normal to write to that 2000 address, which is no op. Yeah. Okay. So we will assume then that it is a no op, but I'll probably print here println. We should probably handle ROM bank, multiple memory banks, return but I mean, what will this fix? It will just call this over and over and over and over and over and over and over. So whatever is wrong is not wrong here, but might be wrong after. Might be wrong after. So maybe what I can do is if this, I do self last instructions dot clear, because I'm trying to grab that context there. Okay, so if I reach there, I stop, I clear, and then I start pushing stuff. And I start writing. Hold on, where am I pushing? Okay, I'll try this. So this should clear whenever I reach there, and then this will store the next 100 instructions, 1000 instructions. Okay, this is whatever, and then if I log, these are all the instructions that run after that. So maybe whatever the issue is here, right? So this is the first one that we already know, and then we are writing CFFF into the stack pointer. CFFF into the stack pointer, which is the limit of the work RAM. Then we are writing 0 to XOR. Then we are writing DF to HL, and the F is another work RAM, and then we are writing 0 to B, and we are writing 0 to HL, decrementing B. So this is essentially just clearing the RAM. Right, so this will clear 256 bytes. This will clear 256 bytes of HL of the work RAM, this one. And then it just does this a shit ton of times. But because each one is 1, 2, 3, 1, 2, 3. No, actually this might do it 512 or 511. Yeah, but this is just doing the same thing over and over again. Ay, ay, ay. I'm just scrolling, trying to see if I get something different. 260 to 61. But yeah, I think I will stop the stream here. So we ended up not getting anything. Okay. So here we jump to... Now here we continue. And then we write CF to HL. We write 10 to C, 0 to B. We write 0 to HL. And we decrement B. So we are going to do this again 250 something times. Yeah, so we are writing okay. So what happens if I do this now here? I'm just trying to grab context. Like I don't know, man. I don't know. Okay, but now this is doing the same thing, but for CF, which is the first work RAM, the first 4 kilobytes of work RAM. And it is doing this 250 something times as well. And scrolling and scrolling and scrolling and scrolling until something changes. Okay, till here. Non-zero. Oh, and then it decrements C. So C was 10. Right? C was 10. This was this. So it will essentially try to do this 2,500 and something times. Right? So I think that what I need to do here is to 7 to 71 to 72. I mean, I'm so invested in this. I might as well just work on this the entire day. I don't even know. I just want to fix this. I just want to fix this. Go, go, go. Yeah, but I will, I need to make a break. I need to go have lunch. 272. Okay, then it writes 9Fs to a gel. 9Fs is this, the video RAM. And then it does... Well, we just lost someone, because I have all the stats now. We just lost someone that was watching the stream for 45 minutes. And they didn't even follow. Very sad. Godspeed, my guy. This one is for you. Sad. Okay, so 9Fs, it's gonna do this 200 times 256. 20 times 256, so this is like 1k. 5. Okay, so it's gonna clear 5k from 8k memory. Just writing zeros there. 27C, 7C, 7D, 7E. Okay, then it decrements C. And then it tries to do the same thing for FEFF. Not usable. Nintendo says this is prohibited. What the hell? Why are they trying to... FEFF. Why are they trying to write here? Not usable. On the MG, reads... I mean... They are doing something there to FEFF, which they shouldn't. And then they are decrementing by... I don't know how many times. But they're essentially clearing a bunch of memory. Probably to clear the OEMs, right? So we are probably clearing the OEM. 290. 286, 87, 88, 86, 87, 88, 86, 87, 88. And then somewhere here it tries again to FF, FE. And clears B, clears 80 bytes of here, which is all of the IRAM. Your green circle has moved. Green circle? Top left? What? Camera green circle. I'm very confused right now. Camera green circle. What does that mean? Look at Gameboy screen. Stream. Oh, it's the thing. Yeah, it's the because if I rotate the chair. Thank you. It's the chroma keyer.